Nobody said anything when I was making my change the other day. I forgot to write in quiz. I said it, but I didn't. I put it back. We're going to go over two questions. Going to get going on our solving 2425. Next Tuesday, we're going to complete 2425 with whatever we have left to do. 2425 is a lot of examples and showing you how to use the different methods for solving. Questions from whatever questions you have left from the quiz prep from 2-1 to 2-3. Then we're taking the chapter 2 quiz on 2-1 to 2-3. From 1120 to 1150. Now I'm looking at probably no more than you see right there. No more than 6, but I'm probably thinking more like 5 or 4 actual quiz questions. But there's going to be a few bonus questions on there. So here's how averages work. We drop the 2 lowest quiz scores. If you have 100% on every single quiz, and I drop your 2 lowest quiz scores, I'm dropping 200%. Does your average score change? No, it's still 100%. Okay. If you have 2 quizzes that are over 100% and I drop a couple of 100%, yeah, it's going to go up higher. Because now there's fewer quizzes to average in, and you have more bonus points versus the 100%. Okay, so everybody's, that's why people ask me, what do I have to get off the top of my head? I can't tell, because everybody's average is going to change differently with respect to your overall quiz average and where your lowest quiz scores happen and your highest quiz scores happen and what happens when it gets dropped. So if you have zeros and we drop zeros, it's going to change dramatically. Obviously, because zeros are really hurting you. And when you have opportunities to get bonus points, that definitely raises your overall quiz average when we drop the zeros, because you're adding in points that are not going to count against you on the zeros. So here's the deal. It's called opportunity. And I had to remind my gym class about this yesterday. But so animal video is just that's our entertainment sometimes at night. When it's a bad day, we gotta pull the animal videos. Question is, what kind of drug is that cat on? Because I know cats will just start attacking people. There he is. Do you know who that person is? Well, yes, people listen to know why he's important. It's Prime Minister of United Kingdom of England when World War II split up to Germany. If it wasn't for him and a little known mathematician by the name of Alan Turing. It was mathematics that helped win World War II, by the way. He's famous for the imitation game movie, AI. But the idea was who broke the Enigma code. And it was the German codes that were broken that allowed the Allies in certain situations to defeat Germany. 3 mathematicians, actually 4 mathematicians. Wait, I take it back, 5 mathematicians. However, the woman that was also the mathematician, they wouldn't count her as a mathematician because she had worked in the secretary force. Yeah. But she was part of that group. He said, you're actually brighter than the other guy. So she was a sneak over to him. Or a pessimist sees the difficulty in every opportunity. It's too hard. I have to go all the way down. I know the winning lottery numbers for next week because somebody from the future came back and told me, but that store is like $2 away. That's difficult. I can't get there. Too hard. An optimist sees the opportunity in every difficulty. Opportunity. Raise your overall quiz out. When people ask, what can I do? Then tell them semester. No secret. I give you examples of the test before you take the test. No secret. You practice, do your homework. Just don't write down the answers. Don't have some other thing doing your homework for you. No secret. Learn. Oh yeah, work in school. Learn. And then use me. I'm tired of not getting questions from you guys. You have to be an active participant, not a passive one in your education. Trust me, you will learn more. You will find out that you are capable of more than you think you are if you engage in it. The best education I ever got was when I was going to get my master's degree at Brooklyn Pacific, because everything was based on homework and reading and participation in class. You had to be in class every night, basically the night classes. And it was prove that you did the assignment because we're talking about it. And if you stay quiet and just kind of sit in the shadows, not gonna fly. And I learned more about myself. I learned more about the material than any other class ever did. So you gotta be engaged. So we're going to complete the section 2425. We'll take some more questions on the quiz prep. We'll do the quiz for a half an hour because there's more problems on it. Comes with bonus questions like that. Review sheet you'll get on Tuesday next week. Next Thursday, we're reviewing for the test. Following Tuesday on the 5th, homework is due, chapter 2 test. So which 2 do you want to see today? Number what? Number 10. 10B. Okay. 10B, what's the next one? Go. Number 4. All right. Now, this one did not copy correctly. Number 4 is actually, this is just the answer. I don't know why it did not cut and paste when I wrote down the answers. Number 4 is actually has an extra parenthesis and an extra negative. $85 plus 8 times square root negative 245. And then minus negative 91 minus 8 times square root negative 108. And B. And the B stands for the bonus. So the ones with the B's are the bonus line. This is the formula. If you know what the degrees are in Celsius, then we can convert Celsius into Fahrenheit by plugging in the degrees in Celsius. What is the formula for Celsius? So in other words, if I know Fahrenheit, what would I plug in for Fahrenheit that would change it into Celsius? So if Fahrenheit degrees is equal to 9/5 times degrees in Celsius plus 32. You know how to solve something like this, at least you're supposed to. 3x plus 5y equals 12. Solve for what? Two variables, solve for the y variable because we're looking for y equals mx plus b. If you have 5y equals negative 3x plus 7, and we said, let's solve for x, get x by itself, we should be able to do that. We should know how to do that. If it was negative 2/3 x plus 7 equals 5y, we should be able to undo everything being done to the x and get x by itself. That's exactly what that is. Instead of a x and a y, or y and an x, we have degrees Fahrenheit, degrees Celsius. So I just want to get degrees Celsius by itself. I just want to get the degrees Celsius by itself. First step of solving an equation when it's got fractions in it, because we don't like fractions, is to undo the fraction. The only denominator that we're dealing with is a 5. So undo the fractions, multiply each term by 5. Everybody's going to get multiplied by 5. So we can undo the fractions. So we have 5 times the degrees Fahrenheit equal to, the whole purpose is to undo the fraction, that reduces it. So it's 9 times degrees Celsius plus 160. Now I'm trying to get degrees Celsius by itself. I'm going to solve for the degrees Celsius. So now we undo what's being done over here. The first thing is you get all the degrees Celsius gathered together on one side. So that's it. That's the only one with degrees Celsius. Then you get the constant and everybody else on the other side. So we got to take that 160 to the left side. So we subtract 160. And we get 5 degrees Fahrenheit minus 160 equals 9 degrees Celsius. So now we should be at the step where we undo multiplication and or division. Well, it's 9 degrees or 9 times degrees Celsius. 9 times the degree Celsius. And so we undo multiplication, everybody gets divided by 9. So I could divide each one by 9. So the degree Celsius is equal to 5/9 times the degrees Fahrenheit minus 160 over 9, which doesn't reduce. Or I can divide this by 9 and divide the whole side by 9. So I could leave it as 5 times degrees Fahrenheit minus 160 all over a single 9. That's why I have 3 answers. Okay. There's one other way. I believe it's the way that people would write the equation if they're actually using it. Degrees Fahrenheit, starting over, 9 over 5 times a degree Celsius plus 132 or plus 32. If you subtract 32 first, then degrees Fahrenheit minus 32 is equal to 9 over 5 times degrees Celsius. So we have multiplication and we have division. It's being multiplied by 9 because 9 is in the numerator, and it's being divided by 5 because 5 is in the denominator. So we're going to undo division. We're going to multiply both sides by 5. So this is how it's written. We're going to multiply both sides by 5. So in the numerator, 5 times the whole thing. And we're going to divide both sides by 9 because it's multiplied by 9, which is just the reciprocal. 9/5, 5/9. So 5 over 9 times degrees Fahrenheit minus 32 equals the degrees in Celsius. There's more one way to write it, but all you do is follow the steps for solving an equation to get there, step by step. Okay. Number 4. Number 4, the troublemaker. And the reason why number 4 is such a troublemaker is because of number 5. Number 4. Number 5. What do they have in common?
Square root.
Square root 7. But what else? What's the first thing you notice when you look at them? And the negative.
There's 2 equations.
Well, not equations, they're expressions, but we're simplifying. No, 5 does, but what is the overall question? And the overall question is simplified, but what question is number 4 asking? What question is number 5 asking? Subtraction, multiplication. They're done differently. But what happens? They see parentheses, and so they start multiplying that out because we see parentheses. And it's like parentheses, Pavlov's dog. Rings a bell, starts to sell it. Why? Because psychologist Pavlov would ring a bell and give the dog food. over and over and over again. To the point where all you had to do was ring a bell and the dog would start salivating because associated with bell ringing with food. Didn't have to give the dog food, just rang the bell. Okay. I see parentheses, multiply. No, just subtraction problem. You know how many out of class I usually have to get? I will say at the beginning of the test, make sure you know whether it's addition, subtraction versus multiplication. Make sure. And I still get probably over more than 5, between 5 and 10 people multiply together. Each question on this test is 10 points. 10 points per problem. They get 0. If you do multiplication here, you're not doing the right question. You're doing some, I don't know, you're making it up as you go along. I'm not going to give you any points for doing a different problem. That'd be silly. And you got to pay attention to the question. Subtract. And how we get there is order of operation. Either way, we got to do order of operation. You got to simplify first before you can do subtraction. You would have to simplify if you can before you do multiplication. If you don't simplify first, it's going to be a messy problem. So we simplify first. 85 is pretty simple. Now, simplify the radical. 8 is your getaway car. Let's see what's going to break out of that square root jail. First of all, there's a negative, so I'm going to poke the eye. $245, you're right, it's not a perfect square, so let's break it down. 245 is equal to 5 times 49. How do you know? Well, I know it's divisible by 5 because it ends in a 5. So I just went, hey, 245 divided by 5. You have a calculator, you can punch that up. 245, I know 5 goes to put divided by 5. Oh, 5 and 49. And then 49 is 7 times 7. So you have a 5 and then you got a 7 times 7. So the 7 breaks out, and so you get 7i, and you got square root of 5 left behind in jail. Now that's all I'm going to do for this part. I'm going to go from left to right and bring it right underneath it, top to bottom. And it's still minus in between. I'm going to simplify the parentheses. Then I'll worry about subtraction. It's a negative 91 minus 8. 8's the getaway car. I'm going to see what breaks out of square root, negative 180. It's a negative, so I'm going to poke out that I. 180. Well, it ends in a 0, so I'll use 10. Times 18. Okay. I just picked a couple of numbers. I could have picked 9 times 20. Could have picked 15 times 15 times 12. So just pick 2 numbers that multiply 108. And then 10, we get 5 times 2. 18 is 2 times 9. And you get a 5 times a 2 times a 2 times a 3 times a 3. So a 2 is going to break out. A 3 is going to break out. And 5 goes back in square root jail. So the square root of 180 is 6 square root 5. So negative 8 times 6i square root 5. Now, here's a little bit of advice. If I'm supposed to add or subtract these from each other, the only way I'm gonna be able to add or subtract anything right here from that radical and this radical, they'd have to be like radical. The only way I could add something like this to something like that is the radical parts have to be identical. Over here, I ended up with an I squared root 5. If I'm gonna add this stuff to it, I should end up with an I square root 5. If I don't end up with an I squared root 5, then I'm not gonna be able to simplify a whole lot. I won't be able to add, at least I won't be able to add the radical. But that's what we're hoping for. Now, 85 still, I'm still cleaning it up inside. This is 85. 8 times 7i squared 5 is 56i square root of 5. Okay. I can drop the parentheses because that's what we have left. That's simplified. Be careful over there. Because it's still minus, I'm not done on the inside. And have it, think ahead. Since we're going to subtract, what am I going to end up doing when I subtract? And you're going to distribute the negative and the signs are going to change. Negatives will become positive and positive will become negative when you subtract the parentheses. So I'm just going to wait a second here. Negative 91 still. Negative 8 times 6 is negative 48 I square root 5. Now we have 85. 56 I square root 5 minus negative 91 becomes plus 91. Minus negative 48 I square root 5 is no plus 48 I square root of 5. Like terms, the like terms, the two real numbers, 85 plus 91 is 176. And these are both I square root 5s. So 56 of these I square root 5s plus 48 of those I square root 5s is a positive 104 of those I square root 5s. And I highly suggest that you write this as 176 plus 104 and put the I in between the coefficient and the radical. In the back of the book, you will see it written as 176 plus 104 square root 5i, which would be great if we could count on your handwriting. Because if you write this, you're going to lose points because that looks like I is inside the radical, which is the wrong answer. I can only grade what you write. So I've been giving you advice, put it in between, so now there's no doubt that it's not under the radical. So you want to be clear about what you have. This is clear. That is not. That's kind of clear, so be careful. So don't risk it. Put it between the number, the coefficient, and the radical.
Why do we switch the I? Why do we?
From here to here,
Yeah,
I'm telling you because if you put it afterwards, handwriting. People are not careful with their handwriting, so it looks like it's underneath. There's no reason why they do it. If the reason is you can. You can do A times B is the same as B times A. So 5 times I is the same as I times 5. What do we do with variables? We usually put the coefficient and then the number. But when you have square roots, x times the square root of 2 is better than square root 2 times x, because if you're not careful, it might look like square root 2x. If you put it in front, there's no doubt that it's not inside. That's the mistake. That's the problem. Hammer.
Okay, so do we put it in the front or?
I want this. You want to do that.
Okay.
Okay.
Yeah.
All right. 2.4. We are solving quadratic equations and things that look like quadratic equations.
A question on number 4 real quick. Have you ever really just combining all of your defined terms in your answer where you have square roots of 5, so you're not going, how do the people?
Well, it's like saying, what's 5x plus 2x? Five of them plus 2 of them is 7 of them. So I have 56 of those I squared 5s. Plus, I have another 48 of those I squared 5s. So I combine them to a total of 104 of those I squared.
So that works as an actor.
Exactly. Well, it works as a variable.
A very, yeah.
You know, quantity.
Okay.
It's a quantity.
Thank you.
Solving quadratic equation. Quadratic equation looks like this. A times x squared plus b times x plus c equal to 0. This is called standard form. You should put it in the correct order. Your square should be first, your x to the first should be second, and then the constant. The power should decrease in degree. X squared, x to the first, x to the 0. Quadratic equations in standard form, when all of the terms are on the left side or either side, and it's equal to 0. Equal to 0. So basically, we were solving in 2.1, we were solving linear equations, x to the first. Okay, so x to the first. Now we're solving x to the second. And you're going to have some method that you have to be able to do. So I'm going to let you in on what we're doing. This is a side-by-side comparison of, and I know it's small. I'll bring this up in a second. Side-by-side comparison of the review sheet with the test. There we go. So 140 points, 10 points apiece. So we're looking at 14 questions. The directions are very explicit. Visual direction. If a particular method of solving is specified, be sure to solve it using that method. Otherwise, you will receive zero credit. If no method is specified, you may solve using any algebraic method. Remember, you must show appropriate work to receive credit. And so here we go. The first four questions are not solved. The first four questions are 2.3 on the review sheet. Adding or subtracting. Then you have multiplication. Oh, look at that, squaring something. Rationalize the denominator. And then we start solving. The first one, you have to solve this one by factoring. You have to solve it by factoring. If you don't show factoring, zero. Even if you have the right answer. You got to show me you can factor. Second one, you have to show, well, I take this back. There's 3 examples of a problem where you solve by factoring. I'm just going to ask you one. On the test, you just have to do one. Then we're going to learn how to complete the square. On the review sheet, there's 3 examples of completing the square method. You just got to do one on the test. And then we're going to do 3 examples of using the quadratic formulas in order to solve. On the test, just now you do one with the quadratic formula. You got to know all 3 ways. And after that, it says, solve using any algebraic method. You must show appropriate work. Solve it any way you want. Maybe you want to do all the other ones using the quadratic formula. Maybe you want to do all the other ones using completing square. Maybe, and just maybe, somebody might, for once in my lifetime of teaching, heed the words at the top. Try factoring. It's try factoring. I set up these problems so you can actually get done in like a minute. If you try factoring. Factoring is the nicest, quickest, easiest way to solve a problem. You can be done literally in a minute. Versus the other methods, that might take you anywhere from 5 to 10 minutes because you got to keep track of so many different things. I am posting this today. This is all the different methods for solving quadratic equations. No, you don't get to use notes on your test. But when you are trying to do these methods on your homework and not just copying answers from somewhere else, you need to work through these methods step by step. This is what I will be looking for when I'm grading your work. These steps. I am going to demonstrate every single time how I expect to see it. Okay? So this will get posted. By factoring. Some of you might be able to walk out of here and after finish your test in like half an hour. If you could. I mean, I put this thing up here 3 different ways. Really big, and then I made like a little 2-column thing of it, and then I made this one today, so it had little squares in it. Like, wow, you must be serious about this. Yeah, I think I do. But 1, 2, 3, 4, 5, 6, 7. Solving equations. And do I have a bonus on here? No, I don't. But there's quite a few bonus on the test. There'll be quite a few bonus. Oh yeah, on the review sheet. Look at all those examples of the bonus question. Potential bonus 1 through potential bonus 7. Not even Christmas. Opportunity. Before you ever ask these, ask me these words. Is there anything I can do? I'm showing you right now ahead of time. I'm answering your question right now. Yeah. Look at these things you can do. I don't know if students are asking, if they can watch my card. That's not how you're gonna pass the class. I did have students go over and paint the kitchen, but I was gonna pay them and they just said, we'll do it for free. Don't worry about it. That's good. Anniversary present I was out for my wife. Pretty. I didn't have to do anything. Okay. Homework. We're going to use a homework examples. And the first example we're going to do is number 10. Actually, I take that back. You're doing 7 to 75 every other odd. I want to look at number 6. Okay. And we'll do 7, 6 and 7. Okay. All they want, now do the down where I want to make sure you see it. Sometimes you want to make sure you read directions. Write the quadratic equation in general form, standard form. Do not solve. All they want you to do is make sure you can write it in standard form. Make one side 0. Make one side 0. I'm desperately asking you to not be lazy. This is going to be a challenge for you. Please understand. The worst thing you can do is, all right, make one side 0. Well, I'm kind of tired, so if I just do this, go over to this side, that way I only have to move one thing. So I have 0. I'm still tired. Negative x squared plus 25x. Oh, I only have to move one thing. This is heavy. You don't want to solve negative x squared. Do yourself a huge favor. Keep the square term positive. Keep your square term positive. Even if it means moving 2 things. Keep the square positive. So I'm going to bring these 2 over to the left side so I can keep this positive. So I have to undo 25x, subtract 25x. I'm going to have to subtract 26. Over here on the left-hand side, does it matter what order I write these in? Can I go like negative 25x plus x squared minus 26? Is that okay? Technically it is, but should I? No. We're trying to solve it, and if we're going to solve it correctly, whether it be factoring, quadratic formula, continuous square, we want it in order from highest power to 0 power. So over here, the biggest power of x is x squared, positive x squared. Then you have an x to the first, minus 25x. And then a minus 26. And on the right, you have 0. That's all they want. Make one side 0. Order does matter. Order will help you figure out the next thing. Hey, we got fractions again. Might be a good idea to undo the fractions. You could distribute the 1/5 to each one, but why distribute the 1/5 and then undo the fraction? Right now, you can undo the fraction so you don't have to distribute. The only fraction that has to be undone is the 1/5. So what will undo the 5? Multiply by 5. I just want to multiply by a 5. How many terms do we have on the left-hand side? We have one term. Because it's this times this all together is what then? This is one term, that's one term. When I multiply this side by 5, all I'm doing is undoing that 1/5. I don't distribute it in. As soon as I multiply the left-hand side by the 5, so we go from left to right, 5 times the 1/5, before it can distribute in, it cancels. And don't forget this. But 3x squared minus 10 equals 60x.
So undoing the fraction at the beginning, that doesn't count. I mean, you're just undoing it, so it doesn't count towards your like pen desk, for example, like it doesn't fit in there.
Well, it's undone, so I don't have to distribute, I have to do anything with it. So on the left-hand side, all I have now is a 1. Now, if it was 2/5, then I would still have to distribute 2 into the parentheses.
So then it doesn't count even toward that, and that's
Right.
what you're just undoing it to do that.
Yeah,
Oh, okay.
because I don't want fractions. Now we just got to bring 60x over to the left. So since it's a positive 60, we're going to subtract 60 from both sides. Minus 60x. And it's important that you have the x on it because that over here is going to mandate or dictate where it goes. Is it going to go in front, in the middle, or last? In the middle. In the middle, because it's x squared, x to the first, and there's a constant. 3x squared, and then minus 60x, and then a minus 10 equals 0. Now it's in standard form. That's all we want from you. To make sure you can rewrite it. Oh, that word rewrite. There it goes again. Make sure you can rewrite it so you can start the problem. Simplify both sides. Rewrite. Ax squared plus bx plus c equals 0. Undo fraction. No, after 6 and 7, number 10. So now the directions are explicit. Just like you'll see on the test. You have to use the given method and so on. So we're doing 10. Nine x squared minus 21x equals 0. Or 16. And remember, that is not the homework. The homework is on the homework sheet. These are examples, so you can do those. Don't turn those in, turn in the homework. 2x squared equals 19x plus 33. And 26 is a different method. Directions, solve the equation by factoring. In the co-rec this morning, we practiced factoring. I am posting two things today with your YouTube, and I will also post it in the announcements. Solving quadratic step by step. That's this. This, I'm posting this. So I'm copy that. But I am also posting the factor practice. This. If factoring is frustrating, then these are some examples. Numbers 1 through 12. To review and improve your factoring capability. And then 13 to 21 are examples from 2.4 and 2.5. And then 2.1 and 2.2 down here, number 18 through 20. And I would not worry about number 21. 22, yeah, you can try 22. The solutions are there as well. But the factoring example, okay? I'm happy to help with any of these during office hours. If you want to come and be part of the co-rec, as we do more factoring on Tuesday next week, come on in. Because that's basically what we're doing in the co-recs is we're practicing factoring. We're going over extra homework questions. They're going to get more review for Tuesday's quiz. But you're going to get that post. So the directions say solve by factor. So we're going to solve by factoring. It has to be equal to 0. So you got to simplify both sides, rewrite, and let one side be equal to 0. Step 2, you have to factor completely. Which is a separate set of steps that we covered in the co-rec. Factor completely. So factoring completely, the first step for factoring is take out the greatest common factor. 9 and 21. What's the biggest number that I can take out of a 9 and 21? 3. A 3. The biggest number that can divide into 921 evenly is a 3. And then x squared and an x. I can take an x squared out of the first term, but I don't have an x squared to take out of the second. I can take an x out of the second one. Does the first one have an x to give up? Yeah. So the greatest common factor that comes out of both is 3 times x. When you factor out the greatest common factor, you're reversing distribution. You're reversing distribution. It was 3x times something. When we distributed in, it was multiplication. We distribute 3x in, we multiply. So if we go this way and multiply, when we factor it out, we're dividing the 3x out of each one. So this first term, 9 divided by 3 is 3. X squared divided by x is x. Minus 21 divided by 3 is 7. And x divided by x reduces and equals basically just 1. So it's 3x times 3x minus 7. As soon as you get x to the first, you're done factoring. Because you can't split that up any further. Hence the factor completely. If this was an x squared, I might be able to go a little further. Oh, we're done. Factor completely. Step 3. Let each factor equal 0. This is called the zero factor or factor property. If A times B equals 0, if I multiply two things together and I get 0, either A has to be the 0 or B has to be the 0. That's why we start off equal to 0. If I multiply two things together and it equals 0, one of them has to be 0 because there's no other way to make 0. It doesn't work for anything else. If we have A times B and we got 6, well, that could be 1 times 6, 2 times 3, 3 times 2, 6 times 1. It could be 1/2 times 12. It could be -1 times -6. There's an infinite number of ways to multiply two things together and get 6. But if there's only one way that we can work out, or technically two, to get 0, one of them is 0. So once we have it factored, and it's equal to 0, then either 3 times x has to equal to 0, so you let this factor equal 0, or the 3x minus 7 has to be equal to 0. You let each factor equal 0, and then you solve it. And the way we solve this is we're back at 2.1, 2.2. For solving linear first degree. 3 times x equals 0, so we divide both sides by 3. All right. Make me proud. 0 divided by 3 is? Make sure you know 0 divided by any number is equal to 0. You cannot divide by 0. 0 in the denominator is undefined. Get confused. So 0, and then over here, add 7. We get 3x equals 7. Divided by 3. And we get x equals 7 over 3. On your test at the bottom of the box, x is equal to 0 and 7 over 3. There's two answers. The best thing about this test, since you are solving, you're coming up with the answer for x. Before you walk out that door, and this is all on you. If you come up with an answer for this question and you say the answer is like 8,372, and you're looking at the problem, yeah, I'm going to leave that 8,372. Why would you leave it if you haven't checked it? You have the chance to check it in the original problem. Walking out the door and you have a chance to know if you got it right or wrong. So the original problem was 9x squared minus 21x equals 0. And you can even, you plug in 0. You could probably do that in your head. Let x equal 0. What's 0 squared? 0. What's 9 times 0? I get 0. What's 21 times 0? So minus 0 is supposed to equal 0. Is 0 minus 0 equal 0? So 0 is an answer. I was right. High five myself. And then maybe you need to do this one by hand. Let x equal 7 over 3. Impress yourself. 9 times 7 over 3 squared minus 21 times 7 over 3. Supposed to equal 0. So we have to do the exponent before we multiply. This is 9 times 7 over 3 squared is 49 over 9 minus 21 times 7 over 3. 3 goes into 21 7 times. So I have 7 times 7, which is 49. 9 times 49 over 9. The 9's reduced. So I have 49 minus 49, 0. And when I plug in 7/3, it works. Solve by factors. Number 16. Again, this is where I said, do yourself a huge favor. Make one side 0. Do the work. Don't move the 2x squared. It's a positive 2x squared. Leave your square term positive, even if it means moving 1,000 things over to that positive thing, that positive x squared. So we're going to bring 19x and 33 over to the same side that 2x squared is. So positive 19x, we're going to subtract 19x from both sides. Positive 33, we subtract 33 from both sides. So on the left-hand side, we have a positive 2x squared. We're just taking an inventory of what do we have on our left. Positive 2x squared, a negative 19x, so minus 19x, minus 33 equals 0. Make one side 0. Done. Now we factor completely. Factor completely, we don't have any common factors. The only thing that goes into 2x squared evenly would be a 2. Well, the other ones aren't divisible by 2, so I can't take out a 2. They don't have a 2 in common. Then maybe I can take out an x. Well, I can take an x out of here, and x. This one doesn't have an x to give up. So they have no common factor. So the next step, you actually just need to think for a second. What does factoring look like? Factoring would look something like this. If you started with x squared minus, let's go with minus 5x minus, let's go plus 6. Factoring is like the game Jeopardy. You start with the answer, you're supposed to come up with a question. So, what can I multiply together? What times what equals this? So you know the answer is going to be a parenthesis times a parenthesis. And this would be x minus 2 times x minus 3. That's what it means to factor. You know the answer is supposed to look like a parentheses times a parenthesis. So literally, since you know you're supposed to factor, I'm just going to set up a couple of empty parentheses to work in. And you're gonna get sick and tired of me saying this, but it's a freaking puzzle. And how do you put a puzzle together? All the pieces need to be on the table face up. And what do you put together first with a puzzle?
Yeah.
The edges. Here's my edges. I want to work within the edges. Frame it. It puts you in the right frame of mind. And then you ask yourself one piece at a time. You're kind of undoing the foil. The way you get the first term, focus just on this, forget everything else. What times what? First times first makes this 2x squared. The only way to make a 2x squared would be x times a 2x. That's it. That's the only way 2x squared is going to happen. X times 2x. That's it. So the good news is, that's right. There's no other way. Okay? Now here's the rule about the signs. The next thing, after you go first time first. You want to make sure your signs are right. If you have ax squared plus bx plus c, the only way you get two positives is because in the parentheses, you have a positive and a positive. Last times last is positive and the middle is positive. So the two signs have to both be positive. If you have ax squared minus bx, but plus c. Last times last is positive, but in the middle, it makes a negative. Then inside the parentheses, it has to be a negative times a negative. A negative times a negative makes a positive term here, but in the middle, it will add up to a negative. Yeah, the last two, ax squared plus bx minus c, or ax squared minus bx minus c. If the last term is negative, then the only way to get a last term that's negative, last times last is negative, the signs have to be opposite. One's plus, one's minus. Has to be. That's the next thing, is we want to get the sign. I don't care about anything else. I don't care about the 19, don't care about the 33. All I care about right now is the sign. Last times last is negative. Well, that means it has to be a plus times a minus. That's the only way it's going to happen. So I know for a fact, x and 2x going to make 2x squared. I know for a fact the signs have to be a plus and a minus. Everything I have is right. The last thing is what makes the last term. Now I'm going to focus on last times last makes 33. Again with the puzzle pieces. To make a 33, it might be 1 times 33, or it might be 3 times 11, and that's it. Make a list. That way you don't miss anything, because if you're supposed to figure out all the different ways to make a 48, and you go, okay, my hand going 4 and 12. But there's also like a 6 and an 8. You might miss one if you're trying to keep track of everything in your head. Because you're missing 3 times 16. 2 times 24. There's a lot of ways to make a 48. So again, the puzzle pieces are in front of you. And now you can kind of look at those and think, which one has the best chance of making in the middle 19? Do you think a 1 and 33 are going to combine and make a 19?
No.
So I'm probably going to try 3 and 11 first. And so now what you do is you check the OI. OI is the middle of FOIL. OI stands for outside times outside plus inside times inside. That's how the middle term is made. Outside times outside is negative 11x. Inside times inside is positive 6x. So when we do this with 3 and 11, we get negative 5x, which is not what I want. So when I took the 3 and 11 puzzle pieces and tried to fit them together like this, they didn't fit. So what do you do with puzzle pieces? Maybe you turn one. So maybe I'll switch the 11 and the 3. So now when I do outside times outside, x times -3, -3x. 11 times 2 is positive 22x. -3 plus 22 is positive 19x. Hey, 19. Let's see what the answer is. You don't need a math education either. Okay. I don't want positive. I want -19. But don't trade 11 and 3 because you know 11 and 3 traded is going to give you -5, not 19. When you have the right amount, 19, but the wrong sign, you switch the signs. All you have to do, have the right amount, but the wrong sign. So now the last thing, I just got to switch the signs. This one should be negative, and that one should be positive. So now outside times outside is positive 3x. Inside is -22. And that makes -19 in the middle. Exactly. That is called guessing and checking. But where you want to be is educated guessing and checking. The more you actually practice, you'll see the puzzle pieces fit together quicker. When we're doing this, and I'm looking at 3 and 11, I'm thinking, all right, we want -19. Well, that means I need something bigger minus something smaller. I probably need to multiply -11 and a 2. I'm probably going to want to multiply 11 and a 2 together because that's 22. And then, so, that one's negative. You just kind of start to see things fit together in your head a little bit better. The pieces start to come to fruition. Now that it's factored, that each factor equals 0. If this times this is equal to 0, then x minus 11 might be the 0, or 2x plus 3. That's the 0. Oh, add 11. This x is equal to 11. Subtract 3. 2x is equal to -3. And divide by 2. -3 over 2. This is where we're headed. A lot of you will probably be there before I actually start. If you had this question, x squared equals 25. How can I get x? Was that? What would n do a square? Well, but if I divide by x, now I got x over here in the denominator. A square root. Square root undoes a perfect square, so I get x. And then the square root of 25. 5. The problem is, that's not everything. X squared is 25. What do we solve? We want all of the solutions. All of the answers that make the equation true. Yeah, 5 squared is 25, but is there another answer? What else? what else can be squared that would make a positive 25? Negative 5. If I square a negative, I get a positive. So when you do a problem like this, your job is to remember to put plus minus. But here's the deal. Before the square root method came around, the way you solve this question was factoring. You make one side equal to 0. So I'm going to subtract 25 from both sides. And then you factor completely. Now, for the sake of time, I'm going to go ahead and do this. This is a special case. This is a squared minus b squared. Difference of two perfect squares. So it's a plus b times a minus b. Well, a is x. So b is 20, b squared is 25. So it's x plus 5 times x minus 5. That gives me x squared minus 25. And if I let this one equal 0, and this one equals 0, this is how you get the two answers. And your job is to find all the answers. But along comes square roots. We can take square roots now. So the square root method. The square root method is only used under certain circumstances. So that's why I wrote that up. I'm going to put it up here on the board, along with example number 26. X squared minus 3 equals 78. And number 30, qx plus 3 squared plus 25 equals 0. Square root method. Isolate the constant. This is when you have an equation with a perfect square, something that is perfectly squared, and a constant and a number. So this one right here, number 26, we have a perfect square, x squared, and just numbers. We don't have an x to the first. Perfect squares and numbers. So I'm going to isolate the constant. The constant is the 3 and the 78. Isolate it and we'll put it on the other side. So we're not letting it equal 0. What we're doing is we want to separate the square from the number, add 3.
And we have x squared equals 81. Take the square root of both sides, simplify completely, don't forget plus minus. So take the square root of both sides. Square root of x squared is x equals square root of 81 is 9. And don't forget the plus minus. So you can write it just like that.
What times itself is 81? Positive 9 and negative 9.
You could list each one. X is equal to negative 9 and a positive 9, or you can write it as x equals plus or minus a 9.
Positive or negative 9. But your job is to remember when you're solving, plus or minus. Because we want all of the solutions. On the test, there are no questions where you have to use the square root method. You know, you have to factor. You have to complete the square. You have to use the quadratic formula. Those are your have to's. But it never says you have to use the square root method. But on the review sheet, and I'll point this out when we review. Right there, number 16 on the review sheet looks a lot like number 30 that we're going over right now. And that means something like it on the review sheet. Yes, there's one like it on the test. And every single year, every time I say, all right, now look at this one. Look at what you can do. All you got to do is perfect square. Isolate the constant, square root both sides, don't forget plus minus. Quickest way to get it done. It's a present. And you know what they do? They multiply it out, they boil it out, they're doing it the long way, they're trying to make the quadratic formula work. And only a handful of people get it right because only a handful of people listen to it. Boy, if I could count the gallons of ice cream I eat up now. Isolate constant. So I'm subtracting 25.
We have now on the left a perfect square. It's a perfect square. So the second power equals negative 25.
A perfect square and a number. So undo the perfect square. Take the square root of both sides.
Don't forget, simplify, don't forget the plus and minus. So I'm going to take the square root of this side, take the square root of that side. Over here, it's just going to undo the square, and we get 2x plus 3. Over there, we're going to get a plus or minus. Square root of a negative, we poke out the I. What's the square root of 25? 5. So it's plus or minus 5i.
Plus or minus 5 times I. Square root of the negative is the I, and then square root of 25 is the 5. And don't forget your plus and minus because we're solving. So now we solve for x. So if I'm going to solve for x, the next thing I'm going to do is subtract 3 from both sides. Now, can I subtract 3 from a 5i? No, they're not like terms. Remember, that's the real number. That's the imaginary part. It's negative 3 plus or minus a 5i. Why?
You want to write the answer in the standard form, real number, imaginary part. A plus BI for complex numbers. And the mistake I see when people put the 3 on the other side is then they move the plus or minus to the middle. So always keep the real number before the imaginary. Then to solve for X, and I don't mind which way you do this, however, I will say there's a benefit. You divide both sides by 2. And you got to be careful about how you reduce things. If I divide the whole thing all over 2, you can stop right there because it won't reduce. There's no common factors that we can reduce here. But when you have a question where it might reduce, then you might want to consider this. This will be the safest way if you struggle with reducing fractions. Just like when we solve for slope and all that, solve for y was in that p, instead of dividing the whole thing, if I divide this term by 2, divide each individual term by 2. And now we have x equals -3 over 2 plus or minus 5i over 2. And then if individual fractions reduce, you can reduce individual. It doesn't, so that's fine. Be careful, again, handwriting. Some people are sloppy. In the back of the book, it will be 5 over 2 times I. They won't put I in the numerator. They'll put it 5 over 2 times I. But you can tell that it's 5 over 2 and it's times I. What I see people write is they'll go like this. 5 over 2I. And it looks like the I is in the denominator. That's a completely different number. So if you want to be safe, there is no doubt that I is not in the denominator. So it either needs to be in the numerator or it should be big enough to know that it's not in the denominator. A plus B times. Okay, be careful how you write your answer. So you're getting the notes on how to solve with all the methods. Okay, you're going to get practice stacking questions so you can ask, can you help with factoring? Tuesday, we're going to be going over the 2.1, 2.3 quiz prep. So we're taking the quiz at the end of class. And we'll finish up all the examples, 2, 4, 5. Quiz is always notes on quiz.
Okay, so.
Okay, so I'll see you guys up next week.
That's where, that's where,
Yeah, so the square root of the perfect square.
but then whichever you have to the other side, so that would make.
If I do something to one, I can vote.
Okay.
Let me stop recording. And you need to.